Welcome to this video on converting standard form to slope-intercept form linear equations. By the end of this video, you should be able to convert a standard form linear equation to slope-intercept form equation, and you should also be able to justify the steps of converting between linear forms using the properties of equality. Okay, so we're going to be talking about linear equations, and the standard form of a linear equation is ax plus by equals C. So you have some number a next to x plus some number b next to y equals a constant. This is our standard form. But if we're going to graph, the easiest is to put this into slope-intercept form. And what that means is we're going to solve the equation and get y by itself. And slope-intercept is y equals mx plus b, where the m value, whatever the number is in front of x, this is your slope. And the number that's in the b position, this is the y-intercept, or where the graph crosses or touches the y-axis. All right, so we're going to be using some of the same properties of equality that we used prior to break. So we're going to solve each of these equations to get y by itself. We're going to use the properties of equality to justify our steps, and then we're going to identify the slope and the y-intercept from the equation. So remember, slope-intercept form is y all by itself equals the rest of the equation. So that means we want to get this y right here by itself. There are currently two terms on this side of the equation. We only want one term on that side. So we have 3x, and it's got some addition to the y. So this is a positive 3x. We're going to do the opposite. It's negative 3x to both sides. And the reason we're allowed to do that is our subtraction property of equality. We subtracted the same quantity on both sides of the equal sign, so it remains equal. But what is the first reason? Whenever you start the given problem to you, the reason we wrote it down is because it was given to us. So remember that the beginning is always given. So we can go ahead and write those in. Given and given. Okay, so let's finish solving this. We subtracted the 3x, that cancels it on the left. 3x minus 3x is 0, so it's gone. All that's left on the right is y and then equals. These are not like terms. They cannot be combined, so I'm going to write them in the standard form, negative 3x plus 13. Okay, so remember I said our slope was the number right next to the variable x, so negative 3 is our slope, and our y-intercept will occur where y is 13. All right, let's try this again. Our problem was given to us. Now we want to get y by itself. There's two terms on the side. We need to get rid of the x term first so we can get into the y term. So that's a positive x, so we're going to subtract x from both sides. X minus x cancels out to 0, and that's going to leave us with negative y equals negative x plus 10. The reason we are allowed to subtract that from both sides is our subtraction property. Okay. Now we're still trying to get y alone. This is negative y, and remember this is a negative 1y. I don't want to know what negative 1y is. I want to know what positive 1y is. So I need the negative 1 to go away, so we're going to divide each term by negative 1 so I can get this to cancel out. And the reason we're allowed to do that is our division property. Okay. Negative 1 divided by negative 1 cancels to a positive 1, leaving the y equals. Remember there's a negative 1 here too. Negative 1 divided by negative 1 becomes a positive 1, which is just x. Then positive 10 divided by negative 10, negative 1 is negative 10. Okay? Now, we look, there's not a number written in front of the x. That's called an understood 1. So our slope is 1. And our y-intercept will be negative 10. Okay, let's look at this. What if we don't have a whole number right here for our slope? What's going to happen? Okay, so remember we're trying to get y by itself. Here's y. there's two terms on the side. We got to get it to one term so we can get y by itself. That's a negative 2x, so we're going to add 2x to both sides. The reason we're allowed to do that is our addition property. So when I add the 2x, those cancel to 0, and I'm left with negative 4y equals 2x plus 24. Now remember, we're still trying to get y by itself. This is negative 4 times y, so to undo that, the opposite operation is divide by negative 4. Remember to divide each term. So I'm left with y, because negative 4 divided by negative 4 is a positive 1. Y equals negative 2 over 4x minus 6. And we're allowed to do that because of our division property. Okay, now let's take a look. Here is our slope. I'm going to write the negative sign with the 2 on top. It doesn't matter whether it's on the top or the bottom. But you want to look, whenever you have a fraction, you want to look, will this simplify down into a whole number? Negative 2 divided by 4 is negative 0.5. That's not a whole number, so we're not going to do the division. Then the other thing that you want to check is, can this simplify? And negative 2 over 4, both the numerator and denominator are divisible by 2. So this actually is negative 1/2 when we reduce it. Okay, so you want to leave it a fraction unless it's going to come to be a nice pretty whole number, but you should simplify your fraction. So our slope is negative 1/2 and our y-intercept is negative 6. Hopefully that was helpful. Let me know if you have any questions. I'll see you in class.